Okay, so get this. At CES 2026, NVIDIA dropped something huge. And no, it wasn't just another chip. They rolled out a whole new blueprint for the future of AI. They're calling it the AI Factory. And here's the kicker. This isn't about making AI anymore. This is about putting AI to work, continuously, at a scale that is just mind-boggling.
So, is NVIDIA actually trying to build an AI that can truly reason? I mean, that's the whole game here, right? The entire reason for this insane new architecture is to power a new breed of AI, one that doesn't just spit out answers, but one that actively thinks and works with you, side by side.
And the power this thing needs? It's just wild. We're talking about a single rack, just one, pulling down 600 kilowatts. To put that in perspective, that's enough juice to power dozens and dozens of houses, all crammed into one box, just to fuel this new kind of artificial thought. It's insane.
But honestly, the most jaw-dropping part of this whole thing comes straight from the top, from NVIDIA's CEO Jensen Huang. He basically flipped the old business saying on its head. He's out here saying this new hardware is so good, so efficient, that it's not a cost center. No, he's saying it's a profit engine, a machine that literally makes you money. The more you buy, the more you make. Wild, right?
So how on earth are they planning to pull this off? All right, let's break down their entire playbook. First, we'll look at their big new idea, what they're calling the new gospel. Then, we're diving deep inside the Rubin supercomputer. After that, we'll tackle how they're fixing AI's biggest traffic problem, see how that connects to real-world robots and cars, and finally, unpack the new AI power structure this whole thing creates. Let's get into it.
All right, first things first, you've got to understand that the whole game has changed. For years, it was all about training these massive AI models. But now, we're shifting gears. The new era is all about running them, what's called inference, for millions of real users, all the time. This is the new gospel from NVIDIA. It's all about inference now. And believe me, that changes absolutely everything.
So check this out. This really breaks down the difference. Think about the old AI on the left. It's like asking a calculator for an answer. You ask and answers, done, one shot. But the new AI on the right, that's about continuous reasoning. This is like having a partner, a collaborator, that remembers your whole conversation and actually thinks through problems with you, step by step. And you can probably guess, that kind of ongoing conversation creates a huge, constant demand for a completely different kind of computing.
And the engine behind this is what they're calling a reasoning model. The best way to think about it is you're upgrading from that simple calculator to a true collaborator. See, to solve a really tough problem, the AI has to talk to itself. It generates all these little intermediate steps and thoughts, and every single one of those thoughts creates more data, more tokens, which means it desperately needs a super fast short-term memory just to keep track of its own train of thought.
Okay, so what kind of machine actually powers this thing? Let's talk hardware. NVIDIA is being super clear about this. They are not just selling you a new GPU. Forget that. They are selling a platform, an entire integrated system that's designed from the ground up to act like one giant cohesive AI supercomputer. And this right here is their full stack strategy in a nutshell. It's not about one magic chip. It's about 6 different super specialized chips that are all designed to work together perfectly. You've got the Rubin GPU as the muscle, doing all the heavy AI lifting. You've got the Vera CPU as the brain, coordinating everything. And then you have a whole team of specialists, the networking and data units, whose only job is to make sure there are absolutely zero traffic jams between them.
And the numbers on these components are just wow. The Vera CPU, it's not your standard processor. It's a beast built for one thing, moving data and managing the logic for these new reasoning AIs. Of course, the star of the show is the Rubin GPU, which is a massive 5x leap in performance over the last generation. And holding it all together is the NVLink 6. Think of it like a superhighway that's moving data at an insane 3.6 terabytes per second. Just incredible.
But here's the really crucial part. This isn't just about speed for speed's sake. It's about the economics. Look at this chart. NVIDIA's whole pitch is that Rubin will make running these complex AI models way, way cheaper. We're talking up to 10 times cheaper per token than their last platform, Blackwell. Plus, you can train the biggest models out there with just a quarter of the GPUs. This is the real math behind Jensen's crazy claim, the more you buy, the more you make.
So, okay, we've got this monster of a computational engine, but an engine is useless without fuel, right? And the next big problem, the next major bottleneck for AI, isn't the engine speed, it's the fuel line. It's this massive, ever-growing traffic jam of data that literally chokes the system while the AI is trying to think.
Just think about it for a second. When you're having a long chat with an AI, it has to remember everything you've talked about. That context gets huge fast, and it needs to access any part of it instantly. Your typical computer system, it just can't handle that. The AI ends up spending most of its time just sitting there waiting for data to arrive instead of actually computing, and that just kills performance.
So this context, this memory, gets stored in something called a KV cache. The easiest way to think about it is it's the AI's short-term memory, and it's so important for performance because it means the AI doesn't have to reread the entire conversation from the beginning every single time it wants to add a new word. But here's the problem. That short-term memory gets really big, really fast, and it quickly fills up all the available space on the GPU.
NVIDIA's solution here is pretty radical, actually. They've essentially invented a whole new category of storage just for AI, and it's powered by their BlueField-4 chip. Imagine giving the AI a gigantic, shared, lightning-fast notepad that the entire system can write on at the same time. It's like a third layer of memory. It's way bigger than the GPU's on memory, but way faster than regular storage. And by letting the AI share its short-term memory instantly across the whole cluster, they can boost performance by up to 5x. It's a really clever fix.
Okay, so now let's connect all these dots. We've got the insane hardware, we've got this new memory solution. What's it all for? Well, it all points to one ultimate goal: to power a new generation of AI that can finally break free from the data center and start operating for real in the physical world.
And just look at their roadmap. This tells you everything you need to know about their strategy. NVIDIA is not messing around. They have moved to a relentless one-year product cycle. Blackwell in 2024, Blackwell Ultra in 2025, Rubin in 2026, Rubin Ultra in 2027. This blistering pace is designed to do two things. One, keep them at the absolute bleeding edge of technology, and two, make sure their customers feel the pressure to upgrade every single year just to keep up.
And here's the other piece of the puzzle. It's not just about the silicon anymore. They're pushing out a whole universe of open source models and software to run on this new hardware. You've got Dynamo, which is basically the Windows for the AI factory. You've got Nemotron for businesses who want these reasoning models. You've got GR00T, which is a foundational model for humanoid robots. Yeah, robots. And Alpamayo, which is the AI brain that's going into the new Mercedes-Benz. It's the whole shebang, hardware and software, all from.
So you step back and look at all this insane speed, this fully integrated hardware and software stack. What does it all mean for the rest of the market? Well, it's creating a really clear dividing line, a line between the AI haves and the have-nots. A whole new power hierarchy is taking shape right now. And it basically breaks down into these three tiers. At the very top of the pyramid, you have the giants, the hyperscalers, the big labs training those massive frontier models. They get the brand new stuff, like Rubin, first. Then you have the mid-tier. These are other cloud companies or businesses that are running AI in production. They get last year's cutting-edge tech, like Blackwell. And then at the base, you've got the scientific community, universities. They're often working with even older gear, like Ampere, and still doing amazing things, by the way. So what you have is this incredible treadmill. The top-of-the-line gear for training new models today becomes the standard for running models tomorrow. It creates this powerful pull for the big players to keep spending to stay on top. But it also leaves us with a huge critical question. In this new high-speed race, where the price of admission is a complete multi-billion-dollar overhaul every single year, who actually wins? And more importantly, who gets left behind?
And there you have it. That's NVIDIA's new blueprint for the AI factory revolution. Pretty wild stuff. Hey, if you enjoyed this breakdown and found it useful, do me a favor and hit that like button. And make sure you subscribe so you don't miss our next deep dive. Thanks so much for watching.